that provide clean, green, baseload power 24/7, 365. The JouleBox starts with solar panels that are used to charge the lithium-ion batteries. This is a lithium-ion battery brick which is wired together both serially and in parallel to continuously charge and discharge. This energy management system allows us to operate with the batteries fully charged at all times, not using up the 15,000 charge-discharge life cycles. During operations, we use the solar panels for the LED lighting in the plant. This is a 1 kilowatt brick. Inside the 60 kilowatt JouleBox are 30 kilowatts of battery bricks. We split it into 2 battery bricks, one standing on its edge and one laying down. These are used to power the blower motor and the speed control motors. Because our batteries are kept fully charged at all times, they have a useful life of 20.9 years. The blue DC blower motor is running off the batteries to create manufactured wind in the vortex power turbine. The high-pressure wind goes in the bottom of the vortex tube where it turns the turbine fans, which causes the center shaft to turn. The wind is then vented out the top. The power turbine is connected to a center shaft, which is connected to a gearbox. The manufacturer of this gearbox says the synthetic oil needs to be changed every 3 years. We say every year. This 15-minute oil change is the only time that the JouleBox needs to be turned off each year. All other maintenance of the air filters can be done while it continues to run. The gearbox and speed control motors are controlled by a 60 kilowatt Marathon synchronous AC generator. This is a 60 Hz at 1,800 RPM or 50 Hz at 1,500 RPM. 3-phase, and the voltage can be set from 380 to 600 volts with a power factor of 80%. All AC generators are rated at an 80% power factor. We take the power and feed it into the power queue that will increase the power factor to 97 to 98%. The power from the AC generator comes into the power queue on the left and is cleaned up with the capacitors to 97 to 98% power factor and fed out on the bottom right. There are easy connections for the solar, and the power queue has its own IP address, so it can be monitored from anywhere in the world. The clean power coming out can then be combined with other JouleBoxes, where it is electronically locked down and sent through a medium voltage transformer to the off-taker. I'm starting the blower first. As the RPM slowly increases from 615 RPM to 974, the power turbine is acting like a flywheel. We use this because it helps to stabilize the speed once the system gets up to speed. Because the JouleBox takes time to get up to speed, it should not be used as a backup generator. The JouleBox works best at full baseload power at all times. When the RPM gets over 1,000, we turn on the speed control motors to bring it up to 1,800 RPM. I turn on the power queue so we can monitor it by computer using the IP address. This is the monitoring that is on each JouleBox unit. It shows 59.41 Hertz. We then move up to the kilowatts that are being consumed. I'll put it under different loads from no load to 2.648 kilowatt to a jump of 26-27 kilowatts, then to 42-43 kilowatts, back down to 24 kilowatts to 7 or 8 kilowatts, back up to 10, 21, and then up to 43 kilowatts. All the time, the power factor is at 98.4%. The total harmonic differential measures the quality of the power. Anything below 20% is okay. In the U.S., we get about 8% off the street. We are at 3.93%, which is exceptional quality. We can also monitor the sequence phasor. We monitor by exception over 45 individual components of the power that is being produced. The parameters are set for maximums and minimums, and if it falls outside that range, it sends us an alarm so everyone is notified. This is the inside of our patent-pending proprietary 40 horsepower DC motor that is used as both a speed control motor and a blower motor. While typical motors use 30 kilowatts to create 40 horsepower, we use less than 8 kilowatt for each 40 horsepower motor. Horsepower is created according to the formula of horsepower equals torque times RPM divided by 5252. Nothing in the formula says anything about watts. We increase the horsepower by positioning the strongest neodymium permanent magnets between each coil. Each one is so strong they can pick up over 1,000 pounds. When we turn on the charge to the coil, the magnetic coil flux travels down the stator arm to the rotor. It is combined with the magnet flux to create a dual flux. This dual flux creates twice the torque without using more watts. Then, when the charge to the coil is turned off, the back EMF travels back up the stator arm, creating resistance. But because of the positioning of the magnets, we can create a closed path between the magnets and redirect the back EMF from the coil to the next magnet. By redirecting the back EMF, we reduce the resistance and increase the RPM. We reinforce the conservation of energy that states that energy cannot be created or destroyed, no matter how hard people have tried to destroy the back EMF. We conserve the energy, redirect it so it can be harvested and reused. This is why our motors use less than 200 watts per horsepower. We are not a closed system because of the interaction of the magnets with the Earth's core, but even still, we are not perpetual motion, because our system will eventually stop when the magnets lose power in 100 years. Even though we use less watts to create more horsepower, the laws of physics still require us to be in balance. The formula is 1 horsepower equals 746 watts, or 0.746 kilowatts. We have 3 DC motors that run off the 30 kilowatt battery brick. Each one uses less than 8,000 kilowatts, so all 3 use less than 24 kilowatts. The battery is kept charged by a 30 kilowatt DC motor that is connected to the blower motor. Therefore, the batteries stay fully charged at all times. There are 2 of the 40 horsepower speed control motors and a 40 horsepower blower motor for a total of 120 horsepower. There is a 30 kilowatt DC generator to keep the batteries fully charged and a 60 kilowatt AC generator for output that is used or fed into the grid for a total of 90 kilowatts of generators. The formula of 1 horsepower equals 746 watts, 0.746 kilowatts, is the same as 120 horsepower equals 90 kilowatts. By positioning JouleBox power plants next to substations, we avoid all the expense and losses associated with high-voltage transmission lines. We can provide firm, baseload power, 24/7, 365, to the substation, where it can be delivered at medium voltage through distribution lines. These plants can be sized from 3 megawatts to 50 megawatts each. Each plant is installed inside a prefab, climate-controlled metal building. The units are placed end-to-end and double-stacked on racks. The 3-megawatt plant in the upper left is a building of about 900 square meters, and the 50-megawatt plant in the bottom right is only using 10,000 square meters. The electrical intertie and grid protection is of the utmost importance. Our system was designed by a senior member, IEEE. He is on the IEEE Power Systems Relaying Main Committee and is the Chair Emeritus of the Rotating Machinery Protection Subcommittee. He literally wrote the rules on how to connect with the grid. We synchronize the units in parallel and then lock them down electronically. We use Woodward EasyGen genset breakers, Beckwith intertie grid protection equipment, as well as ABB switchgear and transformers to bring it up to medium distribution voltage of 11 to 33 kilovolts. We are connected via satellite to monitor by exception 24/7, 365 all the different components demonstrated previously. There is complete transparency on what every plant produces, but also on the performance of each JouleBox and even the component parts. It takes 16 to 18 weeks to manufacture the JouleBox. During the same time period, we will be installing the building and laying wires and cable. It takes 8 weeks to ship via ocean container, with usually 2 weeks to clear customs and deliver to the site. 4 more weeks are needed to connect the JouleBoxes together. We usually take 2 to 4 weeks for testing and commissioning. That means you can have power in 7 to 8 months after credit approval. We understand that the JouleBox is new technology, which is why we take the risk out of power generation. We offer a PPA from 14 to 25 cents per kilowatt hour. There are many factors that enter into the pricing, from credit risk, with or without a sovereign guarantee, political risk, currency risk, as well as property insurance risk. If old technologies could have solved your problems, you would have solved them a long time ago. The JouleBox offers clean, green, baseload power 24/7, 365. We assume all the risk. All you pay for is the power that is delivered to you.